everyone, and welcome to another episode of In the Studio. I'm Lynn Weaver, and the program is brought to you by Davis Media Access, and it broadcasts on Davis Community Television. That's Comcast Channel 15 and AT&T UVerse Menu 99. We're also online, so check us out at dctv.davismedia.org. Today our topic is the changing climate and how it's affecting us. And joining me to understand more about this difficult topic, to bring us up to date and to tell us about some of his areas of research is Christopher Kappa. Welcome, Christopher. Christopher is the associate professor in the Department of Engineering and Civil Engineering and Environmental Science or Civil Engineering
yep.
at UC Davis. Sorry about that.
No problem.
Welcome.
Thank you for having me.
For all the attention that the media is giving climate change, I believe that the topic is hardly seductive. The media tends to crush us with data and graphs and the doom and gloom of what's going to happen to us. Is there a way to make people a little more passionate about it and more involved in how to perhaps they can help to change the climate?
Gosh, if I knew the answer to that, that'd be fantastic. That has been one of the challenges for those of us who study this topic and try to understand it and understand that it is a problem. Our changing climate. It's been a challenge to really get action, especially in the U.S. But we slowly see these things changing, and that's good. And especially here in California, we see a lot of effort towards that.
Yes, California is at the forefront of this, at least changing the mindsets of people, I believe. So do you think that we're getting away from the famous or infamous inconvenient truth, and people are beginning to feel a little more hopeful about the climate change and how it will affect us?
I think this is one of those interesting things that seems to go up and down actually on a year-to-year basis.
Really?
That
Yes.
In terms of the public response and the public perception of climate change, it changes with the winds, and that is again one of the things that's proven challenging.
Yes. Politics aside, of course.
Politics aside, but
Yes.
that certainly influences the public perception because, as you mentioned the media coverage, but the media coverage covers a lot of politics as well, and how that intersects with our understanding of climate.
True.
And importantly, the actions that we might take as a society are very much tied up in political will and political decision making. And so in terms of at least action on the large scale, on a societal scale,
yes.
that is certainly tied up in politics. But there is a lot that we can all do on an individual basis, making decisions every day in terms of how we do things like travel, how we just go about our daily lives. There's a lot of things that we can do to minimize our impact on the environment in general and in terms of climate in particular.
Well, that's very reassuring in a way. Just to step back a little bit, how did you ever... I'm not going to ask you how you got involved in science because that's a little bit too personal. But when did you first learn about climate change, and why did you want to involve yourself and your science in it?
For me, it really started when I was an undergraduate in college, and stemmed from a really fantastic professor that I had, and I was able to get involved in research a lot as an undergraduate, thinking about atmospheric chemistry in particular. And then that kind of led me into thinking about the impacts of what we do, of our emissions on the atmosphere, and that kind of naturally led towards thinking about climate change. because I mean, as people say, climate is always changing. It always has in the past and always
Yes.
will. But that doesn't change the fact that what we do can affect change as well, and that it is affecting change.
And that's very, very important, and this is what we're trying to understand, because for a very long time people thought, oh, you know, climate fluctuations are part of nature, part of the earth and space, and we are, it will fix itself in a way. But now we really understand that we are the primary cause of this rapidly occurring change.
Yeah.
So,
and it's actually interesting because as early as the late 1800s, this type of thing was actually predicted in a sense, or at least
really, yes.
A famous scientist of that day, Svante Arrhenius.
Say that again.
Svante Arrhenius,
yes.
I think is how I pronounce it at least.
No.
And
just want to make sure I get the name all right.
And way back then, I mean, just when they were even learning about molecules in the atmosphere to varying extents, made some calculations and had some understanding of how CO2 could actually impact our atmosphere, and came to the conclusion that yes, the globe is likely to warm if we continue to increase our emissions of this type of molecule from primarily the burning of fossil fuels. So although, you know, our understanding has evolved, this basic idea has actually been around for quite some time.
Yes, but none other than the scientific community knew about it, probably, this is very interesting. Now, this month, the White House released the third national assessment, or I should say, the third climate assessment, which is a report, mainly a report, a compilation of world views, scientific views about what the climate is and where it's going and how it will affect us, in the hope that perhaps this report will encourage people, especially the polluters, I suppose, the big companies and the private sector, to come to action. So I wonder if you could tell us in lay terms, what are the latest findings in terms of, you know, how fast is the climate changing, and what are the symptoms in a way?
Sure. Well, so the latest stuff, first we have to look back a little bit and just realize that one of the big things is that every year we're monitoring more and more the emissions and concentrations of greenhouse gases in the atmosphere. And this latest report, as well as many other reports, tell us that these concentrations just keep increasing. Concentrations of things like CO2 and methane and other important greenhouse gases. And so
they increase, sorry for interrupting, do they increase exponentially, or do they increase at the same rate?
They're increasing approximately, well, CO2 is continuing to increase. Methane is actually starting to stabilize with slight upward trends now, after a very substantial increase over the past 100 years.
Yes.
So methane, because of the balances, everything that is in the atmosphere is a balance between the things that emit it and where it eventually goes away. We call that sources of pollution and sinks of pollution.
Interesting.
And methane is currently, we're starting to reach a balance between sources and sinks, and so the concentration is stabilizing more for that one. But for CO2, we're nowhere close to reaching that balance.
And just to make sure we understand, methane is primarily emitted by animals?
That is one of the major sources of methane.
Like we eat a lot of meat, so there's a lot of cows and other animals.
Yeah, through ruminant animals in particular, which are cows. They produce a lot of methane by themselves, as well as the treatment of their waste products actually can release a lot of methane. Rice cultivation is a major source of methane globally as well.
Interesting.
And as something that we've affected, and then an important natural source that we're also affecting in various ways are wetlands. Wetlands are a big source of methane as well. And one other important source of methane that is changing lately is related to climate change, and that's what we call the melting of the permafrost in northern regions. So what that means is there's ground at high latitudes up in, say, Canada, Alaska, places like that, that has historically been always frozen year-round, year after year, never melts. And that's the type of things that we've built, say, oil pipelines on in these areas.
Yes,
and
that's right.
roads and things like that.
We thought it was a permanent
it seemed
element.
It seemed very permanent, and it's melting now in varying extents. And that melting, when the ground starts to melt, biological activity within the ground can start, and sometimes that leads to emissions of CO2, and sometimes that can lead to emissions of methane in these regions. So that's another growing source of methane, actually. That is a result of the changing climate.
I didn't realize that. It's interesting. So this again came out with this report. Yes, and by the way, there is a website that the government has put out, the White House and the governmental agencies, which I think, and I'd like to have your opinion, that is particularly helpful and very well done, and it educates and tries to involve people, and is of course scientifically very robust. And that is the climate change, globalchange.gov, and have you had a chance to go to that website?
I've seen that one, as well as some of the websites from some of the other federal agencies, in particular NASA, the National Oceanographic and Atmospheric Administration.
Yes, NOAA.
Yes. And a lot of these organizations are really making an effort at outreach and education of the public, and not just having websites that just have some graph on it, but actually making them interactive and helping people to understand
that's great.
the problem. So I think that they're really doing a great job in making those more accessible to the public lately.
Well, that's wonderful. What else does the report tell us?
Well, one thing that the report that came out actually since that report, which is
tell me, I don't know about it.
This is from just last week or the week before, and it's actually a little bit disheartening, I have to admit.
Oh, really?
But,
is it sound?
It seems to be sound. New results, we always have to look at them carefully. But a couple studies came out that suggest that the Antarctic ice sheets, so the ice, the glaciers that currently cover
top sheet,
part of it, in Antarctica. Glaciers kind of provide they are their own wall. They keep themselves from flowing into the ocean. So a glacier just flows would flow into the ocean.
Yes.
And the Antarctic glacier in a particular part of Antarctica, that wall has been melting so much that the glacier is starting to really just flow into the ocean, and the new studies have suggested that is now in this part of Antarctica an unstoppable process. That's going to take 100 to 200 years, so we don't need to worry. It is short, it's long, but it's short, and that's the challenges in planning for these things. But it is thought that at the end of this, it's going to lead to an increase in ocean levels and sea level of 6 to 10 feet.
Oh my goodness! So that the impact that comes to mind is the displacement of populations who live, like Bangladesh, for example, who live at under the sea level.
Yeah, under the sea level, or even at sea level.
At sea level. And creating this huge migrations of refugees, this time because of climate change and not because of wars. And what else? So the rising of the oceans. What about these extreme events that we get? Are they simple natural fluctuations, or are they a result of the warming Earth?
That's a very important question, and certainly a very difficult question to answer, because you're dealing with extreme events, you're dealing with small statistics in the end, in terms of figuring out how exactly any given event fits into the historical picture.
Yes.
But what we do know is that especially if we define extreme events as large departures from an average state, right?
That's right.
They're far from that mean value.
The medium.
And if that whole thing is shifting towards higher temperatures, for example, because we know that temperatures have gone up substantially over the last century, then your extremes are going to be more extreme. Mm-hmm. And they're going to happen more frequently.
As we've seen last year and this winter in the Northeast.
Yeah,
yes.
and it's hard to pinpoint any single one thing, any of those, but it is, what we often say is that these are the types of things that are going to happen more frequently, and we need to start to prepare for them.
Yes. Well, the interesting thing is that, so basically the three things are warmer temperature and extreme, the water rising and extreme weather events.
Mm-hmm.
Yeah.
And extreme weather events, it's both things like heat waves are very important. Heat waves can be massively devastating to people directly. It can lead to a lot of loss of life, as well as agriculture and crops. And then on the other side of that is effects of precipitation in terms of extremes, whether it's drought or whether it's actually flooding. It can lead to extremes on both ends.
Yes.
And unfortunately, sometimes the intersection of those, because if you have drought followed by heavy rains, then you're more likely to get flooding. And these are the things that are becoming more more frequent.
So of course the feed and it becomes more expensive. The products become more expensive, the agriculture and everything. But if we the scientists are successful in convincing the general public, the farmers and the manufacturers and so on, that these are really symptoms, will they be engaged and passionate about doing something about it?
One can hope. One can hope.
Well,
I mean, I think I can't say specifically, but I do feel like as people become more aware and as we're seeing more and more of these things, that especially those who are engaged in the daily activities such as farming and things like that, they are becoming more aware.
Yes.
And they are realizing that climate change is as it's occurring today, is not just natural fluctuations. It is some persistent state that's starting to happen, and minds are slowly coming around, being changed.
And especially our children, probably. The very young people will be used to this, just as they have been doing something about profiling and other woes that we've known for a long time. But I would like to know a little more about what you do. I mentioned earlier that you research focuses on aerosols. Now, the first thing I'm going to ask you about that, what are aerosol particles?
Sure. So aerosols, or more generically particulate matter, are pretty simply small particles in the atmosphere.
Yes. What are they made of?
They're made of all sorts of things, and that depends on their sources. Yeah. So some of the key things that they're made of is we have what we call inorganic particles. These are things like how to describe them. They're made from
inorganic.
Inorganic stuff. We have inorganic stuff. We have organic stuff. we have dust as a big source.
Is that organic?
Dust, it would be inorganic, but it's a kind of its own class quite often. We have sea spray as a natural source. We have what's known as black carbon or elemental carbon. That's a very visual one. That it's like when you see a truck driving down the road and you see the big black stuff coming out of the out of the stack. That's black carbon.
Yes.
And any given particle in the atmosphere is comprised of a lot of these different things mixed together in various forms.
Are they tiny?
They are tiny. They're on the order of the width of a human hair or smaller. Actually, quite often much smaller than that. These are the same thing. We think about them now from a climate change perspective because they have an important role that they play in climate. But this is one of the types of things that in California, especially, but also around the rest of the U.S. and Europe, we've been thinking about particles as a form of urban air pollution for a long time.
Yes.
And these are the exact same things.
Okay. Do they cause air pollution then?
They are a form of air pollution.
I see. Yes.
Yeah. And so, we've in the U.S. and Europe especially been working to clean up particles a lot for air pollution purposes.
Yes.
But they also play an important role in climate, and one of the more important things that they do is, if we think about climate and climate change, greenhouse gases, things like CO2 and methane, they tend to lead to a warming of climate. Okay, so particles, though, one of the big things that they do, and the thing that they do on average the most, is they actually will scatter sunlight. So if you go out and it's a really hazy day, part of the reason that it's hazy is because that light from the sun, that light from anywhere else, is not making it directly to your eye.
Oh, okay.
So that light is being scattered in another direction. Now imagine that light is coming in from the sun and it's being scattered back to space directly. It's like it was never absorbed into the Earth system. It never heated up the Earth at all.
Okay.
So particles actually, on average, because they do lots of things, but on average actually have a cooling effect on our climate. They've offset some of the warming from the greenhouse gases.
So this is good.
This is good, except for they're not good for our health. So,
okay.
So there are these competing effects.
Why are they not good for our health? Because of the pollution?
Yeah, they are the pollution. They get into our lungs. They can exacerbate asthma. They can contribute to cardiovascular disease.
So this is a paradox.
It is, and so that's where we can try to choose strategies that will target one thing or another, and we have to think about trade-offs.
Oh, that's very interesting. Can you discover good aerosols that will cool the earth and make people healthy, or at least do not damage, or is that too far of
as far as we understand about particles and health, and that's a whole another day's topic, but on the whole, most particles seem to be bad for you.
Okay.
So it's very difficult to figure that out.
So the attack on climate change should come not on attacking the aerosol particles, but attacking the CO2 emissions and the greenhouse effect and the methane and
we really have to target those aspects
rather than aerosols.
Yeah, because just increasing concentrations of aerosols around us would not be good for any of us.
Yes. Well, I heard it was about 2 weeks ago they had to shut down a lot of things in Paris because the air was not breathable, and that happens. And of course, in China, we know it happens all the time. So.
And San Diego just had their big fires the other week.
That's right. Yes.
And a lot of that was particulate pollution again.
What do you hope your research will achieve? Is it going to be something very esoteric? I'm putting you on the spot here.
Sure.
Very esoteric, or do you think it will contribute to the general good of people?
I like to think it'll contribute to the general good. No, I think, what you find a lot of times in a lot of academic research is it's actually doing both.
Yeah.
We enjoy the getting into the details and understanding the esoteric aspects of things, but we're hoping that in understanding those details, we try to choose problems where those details will allow us to do things like make better policy decisions and inform inform the science behind making policy decisions. And if in the context of climate change, that might be helping to develop better climate models, getting better inputs and parameters within those climate models that we often use to think about strategies going forward towards how are we going to exactly clean things up.
But it's very interesting. Are you often contacted by, or sometimes contacted by big industry or other manufacturers for advice or?
Every now and again. Every now and again, I've talked with some of the oil companies down in the Bay Area a little bit and talked to them about the effects of the one of the particular types of particles that I study a lot, black carbon. That's been
black carbon.
Yeah, the black carbon's been a big focus because that one actually is in contrast to what I said generally about particles is that they
You're contradicting yourself.
I am. It's because they're complicated. So on average, particles have a cooling effect on the planet, but the black carbon type of particle actually has a warming effect on the planet. So people have been very interested in thinking about reducing black carbon on the near term as a near-term climate mitigation strategy as we work towards decreasing CO2.
Yes.
And so I've talked with some of the oil companies and things about those types of particles.
And is it black carbon? Is it what is found in coal, for example?
It sort of. It's actually black carbon is more so it's a product of incomplete combustion.
Okay.
So you're trying to burn your coal, you're trying to burn your gasoline, and you're trying to ultimately take this fuel source, and the ultimate end products are actually CO2 and water. That's the chemistry that goes on.
I see.
And if you get stuck somewhere along that pathway,
yes,
you don't get all the way there, then you can end up with black carbon, and that can happen from coal or oil.
Very interesting. Well, we're almost out of time, but you mentioned the word mitigate, which is very good, and it means compensate, if you like, or slow down the effect. Isn't that a good definition? In about 10 seconds.
Sure.
Can you tell us what we can do, mortal beings, to mitigate this? 10 seconds.
The big thing we need to do is change our energy infrastructure in the U.S. and around the world. Figure out how to produce the energy we need without producing as much CO2 from that. Great.
Well, we're out of time. Thank you so much, Christopher Kappa, Associate Professor at UC Davis of Civil and Environmental Engineering. I got it right this time. Thank you so much for what you do. And thank you, all of you, for watching. You've been watching in the studio. If you'd like to see this episode again, you can go to our website at dctv.davismedia.org. And while you're there, you may want to check out some of our other interesting programs. From all of us here at Davis Media Access, and especially from the wonderful crew and myself, thank you so much for watching, and see you next time.